Hello Internet, my name is Quinn and this is Blondihacks. I'm back on the Pennsylvania A3 switcher locomotive build this week. I'm going to build the frame for the tender. It looks like a very simple structure, but there was some surprisingly tricky operations in this one, and a few things went wrong that I had to recover from that I think you'll find interesting. So let's go. This is where we left off last time. The trucks are looking pretty sharp, but well, moving them with my hand like this is not very sustainable. Really, we need to connect them with a frame. To that end, I've got a bunch of brass square bar for the purpose. Let's see, put one there, one there, one there, one there, and then perfect. Done. All right, video over. Thanks for coming, everyone. I'm just kidding. We need to do a little better job than that. It's funny how sometimes the simplest parts turn out to be the most interesting. At the end of the day, this frame is 6 pieces of square bar with the ends squared up and a bunch of holes drilled in them and screwed together. Couldn't be much simpler, right? Well, a lot of very interesting things happened along the way. I started by rough cutting everything on the bandsaw and cleaning up one end. I'm starting with the side sills here, which are the longest pieces. I cleaned up one end of each of the 2 sills. Then for the other end, I gang milled them together. I lined up the far ends that we just machined with a 1-2-3 block to get them perfectly even, and then I machined the other 2 ends together. The tricky thing with these parts is that they are too long to measure with any tools that I have. I don't have a caliper big enough, and they are too long to measure with my DRO. I don't have enough table travel. So I'll be measuring them with a scale, which isn't super precise, but that's okay here because what's less important than that they be the exact correct length is that they be the same length so that my frame is very accurately square. So I'm checking my length with a scale, but they've been machined together, so I know they'll be okay. What's more interesting though is that while one of these pieces is nice and straight, one of them is not. I checked them both on the surface plate to see if there's any bend or twist in them since this is a frame. And sure enough, one of them has quite a bit of a banana in it. It's got a lot of rock when sitting in one position, and when I flip it over, I can see daylight underneath it. So it's probably not serious enough to worry about, but I have to machine these sills down anyway. The stock is overly thick, so I might as well take that banana out while I'm at it. I've got it set up on the mill table with the high spot in the middle. In machining, there's a special technique for removing bend or twist from stock. You can't just clamp it down and machine it thinking you're making it flat, because then when you release the clamps, the bend is still there and all you've done is make it thinner and it's still bent. What you actually have to do is support the material under the bend. So I used a feeler gauge to find out what the clearance under it was there at the worst part of the bend. Then I put shim stock under there of that thickness. Now I can clamp it down and touch off on the high spot, which is the center. You can see how the cutter stops touching the work once I move away from the center because that's the high spot. Then I go down to the end and touch off there and machine everything flat from here. I do a very light touch off on the end because as we get towards the high spot in the middle, of course, the cut is going to get heavier. So if the bend was severe, you could get too much depth of cut here. You got to watch that. For clamping, you'll see I've just used regular toe clamps on the top, which means I have to play musical clamps. Ideally, you'd use a side clamping system. I actually made some side clamps many years ago, but they're too tall for this piece, so I have to play musical clamps and machine around them. Side clamps wouldn't work on stock like this anyway. It's too thin, and because it's brass, you would damage it. Of course, I feel foolish having cut the excess ends off of this stock before starting because I could have used the excess material to clamp the ends and not have to move the clamps, and then machine them down to the length after thinning them down. But, you know, here we are. Now at this point, this surface is flat, but the other side is still curved. Here's a diagram to show how that works. By supporting the bow in the middle and then machining it flat, what we've done is thinned the material out in the center and the edges are still thicker. In fact, here you can see if I measure in the center and then measure at the ends, you can see that the ends are thicker. And that's how we're removing the bend from this material. So now when we flip it over, it'll sit flat and we can clamp it down and machine it down to final thickness. We'll be removing more material from the ends than we do in the center, but when we're done, the sides will be parallel, everything will be even thickness, and there won't be any bend in it. This is a great technique to keep in mind if you're working with castings as well, because castings are frequently a little bit warped, and so you have to support the warped areas of them and machine them flat using the same method. I demonstrated this on the base casting of the big steam engine project I did a little while ago. Check my playlists for that if you're interested. Well, everything was going great here. I thought I was just about done, and then the final pass on the final cut of the final piece, and yeah, I wrecked it. I misread the DRO, I lowered the cutter too much, and possibly scrapped this part. Or did I? I think we can fix this. And I think it's worth doing because I don't have any more of this stock and I would have to wait a week to order more. So, as with most repairs, step one is make it worse. I'm going to machine out a pocket in the area where I messed up the cutter depth. Here's the result of that. I've got a nice square pocket with a registration shoulder on it that I can put a piece of scrap material in, and I'm going to silver solder in a new piece, and then once we machine it down, you won't even know it's there. I'm going to drill and tap a fixturing screw hole between the two pieces to hold them clamped together during silver soldering. I'm using strap clamps to hold the pieces down to the table and a toolmaker's clamp to hold them square to each other while I do this. So this piece is in the final position that it will be in for soldering. I tap drill through, clearance drill the top, and then thread the bottom. Now I can tighten a little bolt in here, and that little bolt will clamp the two pieces together. The bolt is brass, so it'll just be machined away afterwards and you'll never know it was there. All those pieces went in the pickle bath for silver solder prep, and now I'm setting them up here on my hearth for silver soldering. I'm going to get some flux on there. Here's a Kozo trick. Some center punches on one of the surfaces will keep the parts suspended very slightly apart and give the silver solder room to flow in between. That makes a much better joint. It's a little tidier if you do that before the flux, but yeah, I forgot. Now bolt those together and we're ready for some heat. The parts will be held square by the registration shoulder, but a little double checking doesn't hurt. Okay, set up for heat now. I've got a piece of solder along the top and I'm going to heat the whole thing up until that solder flows. I was a little bit lazy here and I'm using my small torch because I didn't want to go and dig out the propane tank from the outside storage. I really should have though. This is not enough torch for this. I struggled to get the whole assembly hot enough because of how much mass of brass there is sticking out the end. I did eventually get it though, and the joint looks pretty good. It would have been a little better if I'd had more torch, but we got it done. Now I can machine off the excess on this block. Obviously you could use a much thinner piece for this, but I had the block literally sitting on the workbench because I had just cut it off, and brass is so easy to machine down that it really doesn't take any time anyway. This whole procedure would have been quicker and easier in steel because you can just lay some weld down there and then machine the weld flat, but this being brass you can't weld it, so silver soldering in a piece is the next best thing. If done well, this repair will be invisible, especially after paint, and silver solder is actually stronger than brass, so you don't have to worry about the strength of the repair. I machine that flat until I can't feel any ledge there at all. Now I just need to machine the end. For this, I've brought in the other side sill again, and I'm gang milling them once again to bring down the repair to the same surface. I'm going in a little bit at a time, trying to just touch off on the piece that was silver soldered. Once I've got a light touch off there, then I machine all the way across all three pieces. And the reason for this is if I accidentally remove a little bit too much from the repaired piece, I'm also going to be removing that from the other side sill, so they will both still be the same length, which again is much more important than them both being exactly a specific length. Here's the two side sills brought to dimension now and straightened out. On the one end here on the lower piece, you can see there's the repair. If you look closely, you can see a little bit of the silver solder color there, but essentially that repair is invisible, especially after it's painted. So that's a good technique. Keep that in mind. You don't necessarily have to scrap the part if you make a little boo-boo like that. That repair took about an hour, but it saved me a week of waiting on the project. Next up are some cross holes in these sills to mount the cross members. So I'm centering up with the edge finder and I'm finding one end because this end is where the holes are measured from on the drawings. This is a good example of when to use absolute and incremental on your mill. The drawing gives the dimension for the center line between these pairs of holes, and then it also gives the spacing of the holes. So an easy way to do that is to edge find one end, then move down to the center line on the drawing, then switch to incremental mode on your DRO, 0, 1 hole, and then use the incremental mode to measure the distance to the other hole, drill that one out, and then when you go to do the next pair, you switch back to absolute and you've still got your global coordinate system on the part, and you can do the same trick at the other end. And at the other end I had to use a machinist jack there as well because I'm sticking way out of the vise. Now things get interesting again though. I need some holes in the ends of these very long parts. These parts are much too long for my mill, And I could do them on the lathe with a cross slide setup, but the spindle on my lathe doesn't run fast enough to run the tiny drills. So I need to do this on my drill press. That's the only machine I have that has both the Z height and the spindle speed needed to do this. But of course the drill press is not accurate enough for this. So what I'm going to do is I'm going to make a drilling jig, and that's going to allow me to transfer the precision of my milling machine over to the drill press. It's the power of a drilling jig. I'm going to machine out a little pocket. This pocket needs to be perfectly square, and of course you can't mill a perfectly square inside pocket on a milling machine because cutters are round. A common way to do that is to mouse ear the corners of the pocket, but this pocket is too small to really bother doing that, so instead what I've done is I've milled straight through on the ends, and then I'm milling a little bit of a cross hole in the center. So it's a funny looking shape, but once I deburr it, you'll see how this actually forms a rectangular pocket in the middle and didn't require any complicated mouse ear operations. See how the end of the side sill fits nice and snug down in there. So it slides over just barely, and there's no wiggle in that part, so that'll be a nice accurate drilling jig. And being steel, it'll hold up to multiple holes. Now I can accurately drill the holes relative to where the sides of the brass will be when they're in this fixture. Those holes are going to guide the drill press so that the drill press is forced to be precise. This fixture is a nice close fit on the end of the brass, as you see there. One more time, just because it's really, really cool, and I never get tired of things that fit nicely together. Over to the drill press then, I'm going to set this up with a toolmaker's vise on its side. That's going to give me a nice repeatable setup in the XY plane because I have multiples of this piece to do. Conveniently, they fit through the center hole on my table. If they hadn't, I could have just swung the table to the side and mounted the pieces to the side of the table. It's an advantage of a round column machine. You can do stuff like that. Now to crank up the speed. Amazingly, this budget-friendly DIYer drill press goes all the way from 140 RPM to 3050 RPM, which is a very impressive RPM range for a hobby-grade machine like this. So thanks for that, Grizzly. Hashtag not sponsored, but it's a good machine for the money. Next, the drilling jig goes on there, and I've already lined it up with the drill. It just has to be pretty close, line it up so that the drill isn't bending as it goes through the hole. And doing that by eye and by feel is going to be accurate enough because the steel fixture is going to guarantee an absolute level of precision that we need. For depth, I've just marked the depth on the drill, adding the thickness of the drill jig to that measurement. There we go, one down. Unfortunately, the hole in my table is not big enough to reach both holes from one setup, so instead I'm just pulling the piece out, flipping it around, and putting it back in. This is super easy because that toolmaker's vise ensures that this setup is repeatable in X and Y. It does not repeat in Z, of course, because it's arbitrary as to where I clamp on the piece, but that doesn't matter because all we care about is the drilling depth, which is marked on the drill itself. I'm having to go very carefully here because with this big drill press quill, I don't have a lot of feel, and 3000 RPM is a pretty good lot of rip'ems, but it's still a little too slow for a drill this small, so I'm feeding very carefully to make sure I don't snap that drill. With all 8 holes drilled, I can use this same setup for the tapping, using the drill press to ensure that my tapping is nice and square. However, I did have to lower the table for that, and the downside to a round column machine is that when you move the table vertically, you lose the XY position. I was able to get it back in line sufficiently by using the drill guide to hold one end of the tap and just knocking the table around until the tap was visually square on both axes. This is good enough for tapping. Tap wrenches don't have to be absolutely perfectly to the 1000th square, they just have to be eyeball square. Another way to do this would be to enlarge the holes to the clearance size at this point in the drilling jig and then use the drilling jig as a tapping guide. That certainly would have worked fine, but I already had this set up here, and this way I can use the drilling jig again if I need to, if I scrap one of these parts or something later on. Next up are the cross members. There's 4 of them, 2 cross braces and a front and back piece that are kind of like bumpers that hold various attachments. These are easy to square up because they're slightly wider than my vise, so I can mill one end and then move down on the DRO the length of piece that I want plus the diameter of the cutter, and that's going to be dead nuts on size. It's nice when that happens. These pieces need a whole lot of holes drilled in them in many various places that I'm not going to make you watch. What is interesting though is that the hole patterns on the various sides of these various pieces are not all symmetrical, and that is a real test of your ability to read the orthogonal projections on a drawing, because you got to make sure that they end up off-center on the correct side relative to other features on the part. Also, some of these holes are dimensioned a little strangely, so I did some math and kind of redimensioned everything off of a center line, which I find much easier to process on my DRO. Like the side cells, these have a hole pattern in their ends. Unlike the side cells, they actually fit in my milling machine. I am going to use the same setup that I used on the drill press with the toolmaker's vise on its side, this time indicating it in square, which is necessary because I'm not using a drilling jig here. I'm going to be using the DRO, which is going to be faster than making another jig. I'm not doing this in my regular milling vise because there would be a lot of stick up and it would be difficult to get them perfectly square. So with the toolmaker's vise on its side and suspended on some 1-2-3 blocks, I have very little stick up, and that toolmaker's vise is holding the parts perfectly square for me. Plus, this fixture is easily repeatable because the bottom of the vise repeats in X and the jaws repeat in Y. And in fact, this repeats in Z as well because the end of the part is sitting on the milling table. A bunch of these holes need to be countersunk for the screws, and because they're imperial, they have an 82-degree countersink on them. Unfortunately, weirdly enough, I don't own an 82-degree countersink tool. I have a whole bunch of 90s and no 82. I was going to buy one, but when you own a D-bit grinder, there's really no excuse for buying tooling, so I decided to go ahead and make one. I keep these split carbide blanks in stock for just such occasions. It makes it really quick to make simple little cutters like this for the lathe or for the milling machine on the D-bit grinder. I have the head set to 41 degrees, and I'm going to start by creating the shape of the cutter, grinding in one side all the way down to my center line at a 41-degree angle, which will then create an 82-degree countersink when it is finished. Next up are the clearances. I start by flipping the part 180 degrees, and I grind the other side to the same 41-degree angle. That will clearance the back of the tool so that it gets out of the way as the cutting edge creates the angle. Then I go into free spinning mode on the head, and I use that to grind the clearance on the back of the tool, so that as the tool spins, the leading edge will create the shape and the rest of the tool will just get out of the way on the way around the hole. Creating this round, smaller radius clearance angle that's the same shape as your tool is really the superpower of the D-bit grinder. That's what makes it so easy to do with this machine. That would be a pretty difficult clearance angle to create any other way. Here it is in action on one of the holes that needs to be countersunk. I had done a test part already, so I know how deep to go, and I'm measuring the depth on my DRO to get just the right depth for the screw to sit nice and flush or a little bit below. You can see how beautifully that tool is cutting. It's really working nicely. That's a beautiful little countersink, and that screw sits down in there just perfectly. Really pleased with that. Here's the test part that I used to dial in that cutter. You can see on the right is the first attempt. It was rubbing a little bit on the back, so the material's pushed up and the hole's a little gnarly. I had to add a little bit of clearance, and then I got the hole on the left, and so I knew I was good to go. All right, let's do some assembly. We've got all the pieces of the frame done and ready to go. You can see how the pieces all screw together really nicely there. Pretty pleased with how that all went. It's very satisfying to grind your own tools and then get a nice result from it. Now, a couple more pieces to make. We need to make the kingpins that the trucks pivot on. For that, I've got this piece of stainless with which I'm going to make both pins. I'm going to face off the ends, as is tradition. And I'm going to need a center in that because I'm going to have lots of stick out, and these are going to be thin parts. However, I don't want a center in the final part, so I'm going to do a little trick for that, which I'll show you. Pull myself out enough stock to work with, put the center in there. I need to turn down the stock diameter a little bit. The stock I'm using is just slightly bigger than the final pins need to be, so a very light cut takes care of that. The green goo that I'm using there is Anchor Lube, hashtag not sponsored, but it's what I like for stainless. Check my measurement in a few places. I thought I'd make these pins out of stainless because then I don't have to worry about corrosion. They're kind of down in the weeds on the trucks, so corrosion could definitely be an issue. That looks like a good fit there, so I can move on to some features. For the features, I need a reference for the end of the part. In order to not have a center in the final part, I'm going to be cutting off the section that has the center in it. So I've scribed a line where the end of the part will be, which I know is clear of the center. And I've got a very thin knife tool here that I'm using to create a snap ring groove. That tool is just 29 thousandths wide. And it's complaining a lot. It's vibrating a fair bit because it's really overly long. I didn't grind this tool. I found this in a bin of high-speed steel that a viewer sent me You can get bins of high-speed steel cutters like this at machine shop auctions, places like that. It's a great investment. It's like buying the wisdom of another machinist. You get tools like this that they've ground and clearly work because they used them, and saves you having to do it. I measured this guy and it happens to be exactly 29 thou wide, so it was probably ground as a snap ring groove tool. If I end up needing that tool again in the future, I'm probably going to shorten it because it was a little scary. I kept expecting it to snap because it was vibrating so much and it's so thin. But it did a great job. That snap ring is a perfect fit on there, so, can't argue with results. At the other end, we need a much wider but very shallow groove, and this is for a set screw that holds the pin into the frame. I think this is really just to keep the set screw from marring up the pin as much as anything. This groove is so shallow that I don't think it's doing anything to really hold the pin in place. It's only a couple of thousandths deep. This grooving tool, however, is cutting beautifully, getting really nice clean ribbons of stainless off of that. Cutting stainless is really nice when it works well, but it'll bite you the minute you turn your back on it. That's all I can do from this setup, so I'll part this off and do the other pin the same way. And Yahtzee. Next I choke up on the part and I part off the section where the center drill is. I measured the end of the center drill that I used so I know how deep this was going to be. If you're wondering how I got lucky doing that, and yes, my parting blade is too low. I should really do something about that. The final feature is a nice taper on the end of this, which I think is supposed to make it easier to install the trucks. I'm not really sure. Doesn't seem to serve a whole lot of purpose, but it's in the drawing, so I'll put it in. I did this on the compound, of course. This being stainless, I don't think I could have got away with using a form tool for this, so I did it single point. There's the two pins right there. Pretty pleased with how those came out. Being stainless, they're never going to corrode, which I really like. I love having stainless parts. Making stainless parts is pretty nerve-wracking. Let's do some more assembly and see how it all goes together. You can see the pins go in the frame like so. The frame is upside down on the bench, and then there's a set screw that goes in one end. Fun fact, that set screw is actually oversized because I drilled that hole out with the clearance drill by accident, so I just went up a thread size. The clearance drill was the tap drill size for the next thread up. It quickly became apparent that this order of assembly is no good because it's pretty much impossible to get that snap ring in there while the truck is sitting on the frame like this. I think that's how Kozo expects you to do it, but I don't know how he does it. Instead, I had to take the pin out and put the snap ring on with the pin in the truck like so, and then lower that whole assembly down onto the frame and then tighten the set screw. But I think he expects you to do it the other way, which is why the big taper is on the end of the pin, so it's easy to lower the tender down onto the trucks. But hey, now I can lower the tender down onto the tracks, because look at that. That is a frame on some trucks. Now it really feels like a railroad car. And oh my gosh, that rolls so beautifully. The heavier it gets, the nicer it rolls, and it's quiet and smooth. Ugh, I could do this all day. And in fact, I did do this all day. I won't make you watch it all, but boy do I have to pee. Here you can see how the trucks turn. They don't turn very much, but they don't need to because, well, trains don't turn very sharp corners. You can also see that I misunderstood how the side bearings work. You see how I removed the paint from the tops of them because I thought those little pads at the top were the bearing surface. However, the bolsters actually ride down in the wider groove and the little pads are just stops. Which makes sense, but there was no assembly diagram that showed how those two pieces went together, so I just didn't understand it and I removed the paint from the wrong surfaces. With the frame on now, you can also really see how the suspension works, and I think that's really cool. If you don't think that's cool, that's okay. Maybe this hobby isn't for you, but I think it's really cool. There you have it. That is the frame for the tender. It's not done yet. There are a lot of accessories still to go on this, and of course it'll be painted. There's some ladders and some footboards and various other things yet to make. I thought I might get more pieces done in this video, but with all of the excitement that happened, the bent stock and the making tools and yada yada, well, this is all that we got done. But like I said at the top, sometimes the simplest parts have lots of exciting operations in them. The size of the part and the size of a hole sometimes makes all the difference for how difficult an operation is. I hope you enjoyed this little process. Thank you so much for watching, and thanks to my patrons who make all of this content possible. I owe you all everything, and I will see you next time.